Good morning, everybody. Welcome, Heidi. Heidi has been with Kai's Educator, I think about nearly 5 years, sort of as long as we have been working on different products. She looked at Kai's Clan, she looked at KaiBot, and then Heidi has developed an amazing program, Math in Action. And this is really focusing from the mathematical point of view. But Heidi, before I start blah, blah, all about it, can you share with us what is this program about and why is it so important?
Yeah, so a lot of the other research that I've been a part of through Marquette University and Sacred Heart University has really focused on integration of computer science, which is absolutely phenomenal. But a lot of times we're creating like these big, huge projects, and they're very teacher driven. So a teacher will create a project, and then when she leaves to go to a different district, if she leaves or he leaves, then the project goes with them. It doesn't stay. It's not part of a continuum. It's not part of a curriculum. So it becomes very hard to scale things when you don't have continuity if there's no scope and sequence. So I really saw a gap in the research with something that was scope and sequence driven. That was aligned to a specific curriculum that K-5 teachers already have to teach. And as a math specialist, I saw an open door for math because math is all about algorithms. So I designed a math curriculum that just so happens to use coding and the KaiBot. And the KaiBot was one of the few products out there that we could use that was totally screen free. And the kids could actually see the math that they were programming in action and running in front of them to see if their algorithms were correct.
And is this program just for elementary schools or where are we, how much have you developed?
So K through 5 has been developed. There is a school district in Durango, Colorado that is piloting the lessons and providing feedback. We're hopefully going to get a National Council of Teachers of Mathematics grant to expand with some testing. And the middle school lessons are in development. So I originally, for proof of concept, did this with one teacher. And that teacher, ironically, after 2 years of piloting, became a middle school math teacher and gave me no choice and said, Heidi, you need to develop these now for middle school. So I'm developing from K through 8.
Oh, that's fantastic. Okay, well, let's jump on. Let me share my screen.
Yep.
Awesome. So you run through it. I've got some coding cards and some tiles here next to me, so I can always try and switch over and we can have a look. But the floor is yours.
All right. So yes, math in action. So the progression really starts with one-to-one correspondence, and then it goes to number representation, addition, subtraction.
Sorry, I'm just trying to, it went back to another screen. Okay.
Yep. Yep. Then go to the next slide. From subtraction, we do a little bit of addition and subtraction. And we do repeated addition, which leads to multiplication, which leads to division, which leads to if-then statements, conditionals, and inequalities, and then finally input-output tables. So you use the coding cards. And with the coding cards, you always have to make sure there's 3 key parts that you need. You need a start card, you need an end card, and then you need a run program card. The one that teachers often forget, and we always remind them, is the hand that says stop. That means stop what we're doing and redo it. So it'll clear the KaiBot and start the KaiBot over.
Yeah.
Perfect. So for kindergarten, for one-to-one correspondence, you're going to use the arrow cards. And when students program this and they run the KaiBot across the coding cards, it'll go forward 1, go forward 1, go forward 1, go forward 1. So we really want our kindergartners to understand that for each forward movement I program, that KaiBot is going to move forward 1 tile. Do you want to show that, Ronald, on the tiles?
Yep, I'm just setting that up.
Yep.
Okay, so let me see, where is my card? Oh, that's the wrong.
And this one-to-one correspondence is often overlooked, and we can't, as teachers of mathematics, overlook this, because when students struggle to understand that 4 means that something will go forward 4 spaces, or it counts for 4 objects, or if something's 8, it means it counts for 8 objects or goes forward 8 spaces. By using the KaiBot and actually seeing it in motion, it gives another dimension other than just static objects. They actually can see the movement. So we're hitting a whole nother level of learners by actually using the kinesthetic movement of the numbers themselves.
So you just switch your little robot on at the back, and once it is ready, it's basically like a barcode. You just tap and scan. So the robot is ready, and when the robot flashes red, that's when you can move to the next card. So I'm starting with program start. And then when I'm finished, I do run. Now for now, I'm just going to put it over here before we start laying out the tiles.
Goes forward 1, goes forward 2, off screen, it'll go forward 3, and it'll go forward.
Good tile.
The teachers that I used it with too, you don't necessarily have to have the magnetic tiles. The magnetic tiles will calibrate to keep the KaiBot centered on the squares. However, the teacher that was using these, she cut out blue pieces of paper that were the same size as the magnetic tiles, just because they had multiple KaiBots, but they only had one set of tiles.
Now, Heidi, I know you were talking about the start tile. Is this, I will just add it there because I think eventually you're going to mention with the maths that we do it. So if I actually tap these 4 cards, if I just run it again, so I'm just going to run my program and I put it on 1, that's going to actually now cause that it's going 1 extra tile, correct?
Yes, it's actually a skill called counting on too, where we can do counting on with students. We can have them place the KaiBot on tile 4 and have them count on to, let's say, 7. So they can do that as well. But yes, so for a start card, just take one of the extra tiles and flip it over upside down so that it doesn't have a number on it. So that becomes our start tile. Whenever we run our algorithms, we always need a start tile to put that KaiBot on before it begins to run the program.
Correct. Okay, so I think we understand that you've got to start, you've got to end, you've got to run, and now we have moved forward 4 times that forward. Okay, what is next?
That's one-to-one correspondence. So on the next slide, our next skill is number representation. So now, go back 1. So the second lesson is number representation. So they're going to remove the 4 individual arrows and replace that with the number 4. That's number representation. So now when they do the forward card and they put the number 4 there, it means it will move forward 4 spaces.
And you'll see on the forward card, it's got like an asterisk, a green asterisk. And what that means is you can now, any card that's got the asterisk, you can add a number to it. Let's go 1.
Yeah. And you can just see it calibrate there a little bit, which is perfect.
4. Okay.
Yep. So that's number representation. Then in kindergarten, that third lesson, we move on to addition. So now they're adding 2 numbers together. So in this case, they would add 1 plus 2. So it would go forward 1, and then it's going to go forward 2. And the students have an Explore worksheet that goes with this, where they can put where it's going to end up and land, which in this case should be on tile 3.
So for those young ones, I mean, obviously you're going to have 1 plus 2 when you move it forward. But you can also go multiply. Hey, you can also go 1 times 2, but that gives you 2, so that doesn't actually work. You have to put your cards a different way to get it for the multiplication.
Yep, and that's why we're really going through this mathematical progression, because after they get addition, before we do something called repeated addition that will lead to multiplication, before they do that, so we have addition, the next lesson for first grade. So kindergarten are these 3 lessons that you're going to focus on and teach right along with your regular math curriculum. So in first grade, we're going to review the addition, just like we did. But then the second lesson, if you go to the next slide, the second lesson will be 3 numbers. And the reason we're increasing the numbers is 1 is it's in the standard, but 2, it's going to set us up for repeated addition, which will be one of our next skills. So here we're just moving forward 3, moving forward 3, moving forward 3. So we want that to be the same number because eventually we're going to go toward repeated addition.
So forward 3, forward 3, forward 3. Okay. I like the fact that we, review what was in the previous lesson, because obviously the teachers, may not be teaching this like 3 days in a row. They may actually teach it over a period of time. So how many lessons do they need to do in kindergarten?
So there's only 3 lessons. So there's 3 lessons that you can do in kindergarten. Now you can make many more ties to the curriculum, but in order to say that we're really truly exposing all students to computer science for all, because that's been a huge push over the last pretty much decade, where we're trying to get computer science for all students. They're all doing it. And as a classroom teacher, I have to teach math. Now I'm just teaching it by adding in 3 lessons a year that cover the algorithm component by embedding computer science concepts. The other thing that's kind of cool with this too is that, and when we watch the Durango teachers do this, when they were coding and scanning the cards, they're actually saying the algorithm out loud as they're doing it. So I heard teachers say, okay, let's record program start. Now we're going to move forward 3, and then we're going to go forward 3 more. And then we're going to go forward 3 more. And then we're going to end the program, and now we're going to run it. So that auditory component of actually saying it as you're doing it helps solidify that math content for students.
I mean, this is amazing. So, you sort of don't even realize you're doing coding. Hey, this is all just from that math point, because just looking at that lesson, very easy. You can see 3 plus 3 plus 3, that's 9. And now you can do so much more just with those cards. So, okay, let's have a look. So that was first grade lesson 2.
Yeah, now first grade lesson 3. So now we're doing subtraction. So instead of going forward on our number line, we're going to go backward on our number line. So you're going to need to take that start tile run out and flip it to the other side.
Okay. So we're going to do it this way. I think you can see it.
So in the Explore lessons that they have, and within the lesson plan, it'll tell students what their starting number is. So for this one, let's put it on, let's use the top algorithm there, but let's use the starting tile of, can you put in there 6? Do 6 tiles?
Yeah.
Yeah, let's
so
do 6 tiles.
4, 5, and 6, or just 6?
4, 5, and 6.
Okay. All right. Go a little bit longer. I'll try to hand with a camera. Okay, so what I've got is I've got 1, 2, 3, 4, 5, 6 over the reflection, and then my start tile.
Yep. But then we'll put.
So I'm going to go backwards 5, correct?
Correct.
And then run that one. Okay. Don't need that one. Okay. Let's have a look here. So I'm going to go backwards 5 in my program, run it, and love it when the robot. See if it's going to work. No, hold on 1 sec. 1 second. I'm going to get this robot.
Oh, you know what? Yeah, actually put it on this 6 run, because in the lesson it tells you that for the subtraction, we don't need that start tile necessarily. So you're actually going to put it on 6.
Okay.
Yep, so put it on 6. Yep.
We're going to go backwards, huh?
Yep, he needs to go backwards.
1, 2, 3, 4, 5.
So 6 minus 5 is 1. Yeah, subtraction, we don't use the start tile. We have to use it for addition, but because we're giving it a number to start with for subtraction, it goes right on the number itself.
Yeah, because if you start on tile 1 and you add 2, it doesn't going to end up on 2. It's actually going to end up on 3. So that's a really interesting concept that we can then explain and have that discussion in the classroom as well. Okay, so what's the next one?
All right, so that's the end of first grade. So second grade.
Second grade.
Yep. Oh, just go ahead and skip this. I had that in there for I see, I think it, I wonder. So that when we do this with other people, it's you want to think about, so what do you see and what do you think and what do you wonder about these lessons as we're going through and doing them? So second grade, it's going to be a review and we're putting addition and subtraction together now into the same sentence. So they're going to start on the start tile. They'll move forward 7 and then they'll go back 3. So it's like adding 7 minus 3.
Okay, so I'm going to end the program and we're going to run it. And we're going to start on the
start tile.
Start tile. So start tile needs to move over here. Okay, so let's work this one up. Start, forward, 7. Backwards, 3. Forward my program. Run it. Move this up a little bit. Oh, what you doing? What you doing? That's funny when you
every once in a while we get a bug. It happens with the students as well.
Yeah.
It does not perform as expected, and that is okay.
That's right. And I know because it's early morning here, the team is not even here. And I've got all 9.5. So one of the big things is just to make sure you've always got the latest firmware update. So when you get your robot, you'll see the first thing is just update the firmware. You just do it on a laptop, and then they're all there. So let me have a look. I think this one is gonna. I'm just gonna try this one again to see if it does a funny thing. Okay. Right. Forward. Backwards. 3. We're going to try test this again. Come on, little robot, come sloth. You can do this. Yes, definitely doing something. Sorry, I just need to get a
might want to use that, or use the hand and clear it out.
Oh, the stop, yes.
Yeah. Sometimes it's a matter of making sure they clear it out.
Yeah, I keep forgetting that. That's a really good one to remember.
There we go.
1, 2, 3, 4.
One of the cool things we've seen with, there we go, now it's going backwards. One of the cool things we've seen is students persevere through the process of problem solving until the KaiBot does what it should do.
So here, clearly, we have now ended on number 4. So 7 minus 4 equals 3. Ah, love it.
Yep. So then in second grade, now we're going to go on to repeated addition. And lesson 2 and 2 and 3 are basically the same thing. You just really want to solidify because they're learning a new skill of what's called a loop. So computers use loops to repeat things. And in math, it's the same thing. When we do repeated addition, we're repeating something over and over. So we embed it in what's called a loop. So we have to start our loop. And when we start our loop, we're going to do our loop 3 times, and we're going to move forward 3 times. That's where the 3 plus 3 plus 3 comes in. And you'll notice too, we've shifted the cards, the coding cards, because we're laying them out now more like a programmer would. So before, when we introduced for kindergarten and first grade, we allow them just to do one straight line. But as they move into second grade, their programs are going to become more complex. So we're going to lay them out more like a programmer would. If students are really struggling on this first lesson for the first time, you can allow them to put it in a straight line, but then encourage them as they move into the third lesson to really segregate out when the loop starts and when the loop ends. So you can see that the start loop and end loop are lined up above and below each other so that they're on that line. That's how programmers do it to chunk their code.
I'll just put it like that so you can sort of see, like now it becomes not that horizontal, but this is how, because when you get to text-based coding as well, you actually do start putting the things underneath. And I think it's just like, in maths when you do times table or whatever, and you go, 47 times 9, you put them sort of underneath each other because it's easier to actually do that. So we're going to do that 3 times, which means it's going to be 9 tiles. You're definitely testing my length of my table here. That's okay. I'm going to add them and go. Okay, so.
Now, before you do it, Ronald, here's a suggestion from the Durango students. So the Durango students and even the teachers, when they were doing this, they wanted it to do like an emotion after every set of 3. So they could really delineate when it moved 3, when it moved 3, and when it moved 3 again. So where you have the forward arrow and then the 3, scan an emotion card. Put in an emotion card after that second 3 there and scan an emotion card. And that was a suggestion by the students. So we're going to change that in the lessons with this next revision process to add an emotion card in there. Nope, not there, because they have to do it after it moves forward 3. It's not the loop. Yeah, it's not the loop. The loop's going to repeat 3 times, but we want it to do the emotion after every 3 moves.
Yeah. So what I quite like, I always say, like because we use these brackets, there's an open bracket and a closed bracket. You've got a start open bracket and a closed bracket. So something has to go in between. Now, often what we actually test with the students is we go, okay, so say you go, okay, so we're going to loop and that's the function we're going to do. But they often forget that. But this is a really smart robot. So if I forget it, I'm just going to give them, we also do sort of a bug detection. So if I go start, loop. Now, if you can see, it actually says bug alert, missing loop number. So then you go, oh, okay. What I've just done here is say to do this once, we need to do this 3 times, and then we start and fix that bug. Now I'm going to do a happy dance, end my loop.
Yeah, and they'll say record program. I'm going to start my loop. I'm going to run my loop 3 times. Then I'm going to move forward 3 times each time it does it. After every 3, it's going to do an emotion. Then I have to close that loop. Then I stop the program and I run it. Like the students will start saying that as they scan the cards. It's pretty cool to watch.
You're going to see you're just going to be about on my lap just now. Oh, line number 9, all at the end there. Okay. Right. So bumped all these, but that's okay. Okay.
Addition. So then we move on to 3rd grade. And we're going to build off this notion of repeated addition and start to do things with arrays. So an array, and what we're going to do is I want you to arrange your tile. Click on the next slide, Ronald, because we're going to do that lesson. So the array isn't going to be 3 by 3 by 3. It's actually going to be 4 by 2. So lay it out 1, 2, 3, 4, 5, 6, 7, 8. So in third grade, they start to look at arrays because they're making connections. And one of the foundational pieces for arrays and the understanding of it is it provides a foundation for area later on. It's really easy for me to look at this, especially with the KaiBot tiles, and say that the area is 8 square tiles because that's the area of the array that she just put down.
Okay, so let me have a look here at my card. So I am going to loop twice.
Yep, and here's where we want to make connections for them. So if you'll notice here, there are 2 rows. So we're going to loop it twice because there's 2 rows in this array. And we're going to move forward 4 because we have 4 columns.
Yep. And then we're going to end that loop. And we're going to end our program. We're still on the board. Yes, we're still on the board. And we're going to end the program. I'm just going to put it over. I'm just going to put it over here. I'll move the camera.
The interesting thing that we found with this lesson before we run this is that there's a couple different ways you can do it. Some students really like to move the tiles. So as the KaiBot goes from 1, 2, 3, 4, they'll literally pick the 5th tile up, snap it up to the 4, and then do the 5 and the 6, or the 6, the 7, and the 8 to make it one huge number line as it's running. Now, the Durango teachers, when they were doing this and practicing, found out that if they took that 4 tile and they turned it 90 degrees to the right, can you try that once, Ronell? Take that tile and turn it 90 degrees to the right. That will force the KaiBot to turn.
What?
Yeah, we found that out. I don't even know if you guys know that. It will literally force the KaiBot to turn without the arrow card.
But then you come down this way.
Yeah, and so what we did is we flipped the tiles then, and then we put 5, 6, 7, 8 the other way, so it could go in a circular pattern across all the tiles.
So like that then, because if it turns right.
Yep.
Like a T. Oh wow. Okay. You see, even we've learned something. Okay, I'm gonna now definitely run out of space here.
So depending, and this would be a challenge activity. Like I would use, for the first activity, I would make the kids move the tiles into a straight number line. Yeah. But yeah, as they go through, and actually, I take that back, Ronald. You don't want to put them like a T. You want to put that 6 next to the 5. You still want a 2x4 array. I didn't see where you put the tiles.
Okay.
Yeah, you still want a 2x4 array. So that's where 5 is. So put 6 under 3, put 7 under 2, and put 8 under 1.
But how does it turn again? Yeah. Do you flip the tile again?
You'd have to ask your programmers that.
We didn't even know that it can do that. So we're going to test this because we have not done it this way. I didn't know it can do it. So you reckon then, because if it turns, then it's going to come this way. So you need to turn this tile this way.
Upside down, I think. Yeah. I think that'll work. Let's try it. Okay. And again, it's amazing. I know, it's amazing what the students will come up with and what they'll figure out. But the whole goal is for multiplication to put it in a loop. Again, we want to move forward 4 and we want to repeat it 2 times so that it covers every number on the array, whether it's a straight number line, whether we, do the turns, but it goes through 1 through 8 consecutively.
See, and already we have got missing loop twice. Then we're going to go forward for end loop. Yep, and you see, it gave me another bug because I had those 2 the wrong way around. So see, another bug. This is what I love. So the kids can actually go and problem solve themselves instead of like just, how does that work?
And when it comes to the mathematics, the nice part is that they're getting immediate feedback. Like if it doesn't land on the number that it should, if it's not performing, in this case, if they would reverse the numbers, it'll perform differently so they can figure out where their errors in thinking are.
What?
Yeah, see? Yeah.
What? What?
I know the students figured this one out. I did not know that it could even do this, but between the teachers and the students of Durango, they figured out it could do this.
Wow.
There's their array.
Why did it go? So because it came here, so that was 1, 2.
Oh,
twice.
you got to put the start tile.
Yes.
Yeah,
But
in the lesson diagrams, these have the start tile. So there is a start tile off the one.
Before the one or after the one?
Before the one. Yep, right there in the top.
Yep. Here. If you start here and you're going to go 1, 2, 3, 4, turn, and then 1, 2, 3, 4.
Yep.
Wow. Okay. You see, even us developers, we've learned something, and I think that's a really, really cool way. So I just want to show them. So we've started there, and then we actually flip the tiles because the robot is reading going forward. But because this tile was rotated 90 degrees, the robot automatically going to turn. So we can then also see what is a left turn and a right turn. Love it. Okay.
Yeah, and they have right turn and left turn cards, and keep in mind that if you're not using these magnetic tiles, the KaiBot won't calibrate. So if you're using like sheets of paper because you don't have enough tiles for all the students, you wouldn't be able to do this. You'd have to put it out into a straight number line.
Yeah. Wow. Okay. I've learned. 3rd grade. You see, I need to go back to 3rd grade. Okay. What have we got on the next lesson?
Okay, so the next one is division. And the cool part about division is that students will really be able to understand what we mean by dividend, divisor, and quotient. Because our dividend is the number of tiles that we're going to have. So let's just use, because of the camera space run, I'll just use those 8 tiles again.
Yeah.
And we'll put the 8 tiles out into a straight number line.
Okay.
Just so we're not dealing with the turning and thing. That was just something that we discovered.
I love exploration. This is what we do. Okay, so it's going to go. Or do we need that start tile?
So you need the start tile on the other end.
Oh, yes. Because she's starting from that side. Okay.
Yeah, and we'll leave it on 8.
8.
So 8 with a start.
Yeah, you might have a bit of a jump. We're going to see. See at the top there, he's got to jump hopefully off there and continue. We're going to test the jumping capabilities of KaiBot. Okay. Now,
all right. So our dividend for this problem is 8. Our divisor, what we're going to divide it by, is how many times we're going to move it back at a time. And this is where students can really kind of do some exploration, because if I start on 8 and I have it move back 3 times, in groups of 3, it's going to fall off the KaiBot or it won't land on the number 1. So we want it to land in this case. You know what? Actually, Ronald, I'm sorry, I made an error here. That tile needs to go back to the other end. So it's an end tile. When we do division, we use end tiles. Sorry about that.
So it's going to be at the start.
So it'll be at the end, because when we're dividing, our goal is to get to the end tile.
Yes. Okay.
Yeah. And so we're going to start with our dividend, which is 8, and that's where we're going to put KaiBot. And let's just try it with moving it back 4. So if we move it back 4 and we have it go backwards 4, the question becomes, how many times do we have to do that in order to get to the end tile?
So 1, 2, 3, 4. And we're going to go 1, 2, 3, 4 on the start card. And I'll put it there when we start coding. Is that right? So twice. Yep.
So twice. So that's the missing number. That's our quotient. So our quotient is the amount of times we have to repeat it within our loop. And the more students do this, the more they really understand the differences between dividend, divisor, and quotient.
Yeah, because I even sometimes get confused of, do you put the divisor and the quotient, the difference of what it is. But this makes it really simple. You just count it out first, and then you see how many times you have to do that. So yeah, very, very simple. Okay, so do you want me to give that one a go?
Sure.
Remember to put your robot facing backwards.
Yeah. Dividend is where we start. So we're starting on 8. We are using the divisor of moving back 4 times. And we are repeating that 2 times. And again, if you want to make it really noticeable of after it moves back 4, you can put in like an emotion card so that it does a little emotion after it goes back 4 and then after it goes back 4 more again.
Yeah, magic, love it. Okay, all right, I think I can pass 3rd grade now. Let's see what next. So I think it's quite important that we probably put in these lessons sort of where does the start tile go.
They in the lesson plans, they are like there's diagrams with the tiles and it'll show you where to put the start tile or whether you're using an end tile and where to put it in the lesson.
Oh, fantastic. So just for the teachers, you can just go on to like learn.kaiseducation.com and the whole lesson portal is there. And I will show you afterwards how we get there. But let's finish with the lessons first. So this was 3rd grade, lesson 2.
So lesson 3 really is an intro to ordered pairs. So when I move something back 13 times, and I only do that 1 time, so if I start at number 13, move it back 13, and I do that 1 time, that's an ordered pair of 113. But on the flip side of that, the other ordered pair is 13-1. So if I move something back 1 time, but I do it 13 times, then it looks very different in coding. And students will say, well, isn't 113 the same as 13-1? And the answer is really no, they're different ordered pairs. And 4th grade will explore it even more. What we're trying to get to with this 3rd grade lesson, though, is for them to understand that if I loop something once, that's very different than if I loop it 13 times. So we're actually going to use a weight. A weight will allow our eyes to actually see that these 2 algorithms are different. So if you go on to the next slide, it'll show us the one with the weight. So if I am going to go back 1 and then I wait 2 seconds, that means it's going to loop that 13 times. So it's going to go back 1, wait 2 seconds, go back 1 more, wait 2 seconds, go back 1 more, wait 2 seconds. It'll do that 13 times.
Okay, so I'm going to go backwards.
Let's just use, because you have 8 tiles, let's just do 6 tiles. Just do 6 tiles. So instead of saying 13, we're just going to say 6.
Okay, sounds good to me. Okay, so we're going to loop something 6 times and we're going to go backwards. Can you do 2 and 4?
Yeah, you can do whatever you want.
You can go backwards.
Let's go back 1 because I'm going to flip it then and show what it's going to look like the other way around. Because otherwise these 2, if you do 2 and 4, it's going to look different. If I do this one, it would look the same without that wait command. Okay. And that's because we're using the same numbers.
So now what am I going to do? Backwards 1, wait, and then?
So backwards 1, wait, put 1 second instead of 2, it'll go quicker. Sometimes students will make choices too, and they'll say, oh, I'm going to wait 10 seconds in between each one. And then they're waiting there forever for it to go. And they realize, oh, 10 seconds is too long. Let's reduce that number. Let's make it 3 or 2 or 1. Okay, so that code now looks like, got the start, we've got a loop start, we're going to loop it, we're going to repeat it 6 times. You're going to go back 1, and then you're going to wait 2 seconds, which is that wait 2 seconds, end your loop and play it. Okay, let's see if that's going to work. Right,
Here we go. All right, take a look. Record program. Oh, really? That's me. It says tap record program twice. Okay, let's focus. Right. Loop. 6. Exit. 1. Wait. 2 seconds. End my loop. End my program and run it. Now I'm going to go backwards. Is that right?
Yep.
On the start dial? No.
Start on 6.
Start on 6.
Yeah.
Okay, hold on. You can just go run program and restart on 6.
So it'll go back 1 and it'll wait 2 seconds. Go back 1, wait 2 seconds. Now what I want you to do after it gets to that end tile, I want you to take the 6 and the number 1, and I want you to flip those.
Okay, so now we're going to repeat only once, but we're going to go backwards 6. Is that right?
And yep. And you'll notice it's going to look a lot different when it runs. It really helps students see that if I talk about an ordered pair of 1, 6 versus 6, 1, they are very different. And we can actually see the math in action when we run the program to see what the algorithm does. So now it's not making that pause. It's going to keep moving back 6.
You keep going. We're on the time here. Go to the robot.
Yep.
Yeah. Okay. So it would then get to the. Okay. So that makes it very, very different, like you say, of what that looks like. So yeah, really, really. So this is how we actually factor those pairs in. So if it's a 13 and you go backwards 1, or if it's a 1 going back 13 times with that wait 1. Wow, that's really fascinating.
Yep. So then we'll go on to 4th grade. So go on to the next slide. So now we're going to talk about inequality. So in 4th grade, we cover concepts like greater than, less than, equal to, not equal to, and this is a perfect spot to introduce conditionals. So a conditional statement states, if this is true, then I want you to do this, and then stop the program. So it's asking if it's true. If it's not true, then it won't do whatever it is we've asked it to do. So in this case, it says if 13 is less than 41, then, and pick one of those, Ronald, whichever emotion you want it to show on the KaiBot. And then we end the conditional, and then we stop recording the program and run. So we're looking if this is true or false.
So how many cards do I need? I mean, how many tiles? You don't need that many, hey?
You don't need any tiles for this. So for 4th and 5th grade lessons, we don't need any tiles. We just need the KaiBot itself. We're looking for the KaiBot in this lesson to display an emotion. If it displays an emotion, the statement is true. If it does not display an emotion, the statement is false.
Okay. Love this. Okay, so now we know we've got to start and an end, and you're going to run it. So what we're saying, if, so it's my if card, if, and we said, let's get the numbers, if 13 is
less than 41.
Less than 41. Let me just quickly, I've got to go back there. Okay, here we go. Start. If 13 less than 41.
Then you need to then called a conditional. Mm-hmm.
Oh, where's my happy? Well, then we're going to have a lonely card. You then have to finish your if, end
Yep.
if.
Then end if.
And if, and then, like always, end your program. Okay, let's move this out the way so we don't get distracted. So start, if 13 less than 41, then make a happy face or a sad face or a lonely face, end your if and run it. Oh, I love it. Okay.
We noticed in watching students as they went through and did conditionals in this manner that they started using the vocabulary of true false versus wrong or right, which is really great, especially if we're looking for differences between fixed mindsets and growth mindsets. If the statement is true or false, I can fix it. But when we have right or wrong, sometimes students have a tendency to shut down because it was wrong. Well, if it's true or false, like I can go back and change true or false. I can rearrange my number sentence to make it true or false and give me the correct feedback.
Yeah, I can. No, I see that. So that's really good. And so it's done as a little amaze dance because 13, that was a true statement that was less than 41. Okay. But I'm sure.
Now, I'm not sure. Right now, we had one other person join. I'm not sure if we caught that on screen, just so you know.
That's okay. I think it's all good. All good. Okay. So
Okay.
I think I've got that. But somewhere I heard something that you can also do something else. What is that?
Yep, that's the next lesson. So the next lesson, we introduce the else card. So in the next lesson, we say, if the statement is true, then we want it to do this. Else, in other words, if it's false, then I want to do this. So now we introduce the else card. So if the statement's true, then do this. If the statement's false, else do this.
Okay, hold on. I need to find another one of my socials. So this is happy, lonely, amazed. And I want to try and find one of the other ones. And just put here, angry, sad, or crying. Right. So you also see that the robot will give you the colors of what you choose. So if we go start, F 13. Then be happy, else be crying. And if run my program, let's see, it should go green. Happy. Oh, yes, of course, it's going to be the first one because 13 is less than 41. So I tapped on the blue one, which was happy. Oh, very, very interesting. So, of course, I can go less than, I think we've got greater than or even equal. So if I go, if 13, equals 13, then you can also have these different social emotional learning cards.
Yep. And you can change your inequalities. You can use, like you said, greater than, less than, equal to, not equal to. So the Explorer worksheets and the exercise has the student inputting certain values, and then they have to determine if it's going to be greater than, less than, equal, or not equal to get the right emotion. So the lesson will set them up for that.
Yeah, and I love the worksheet. So with each lesson, there's the lesson and then there's a worksheet for the students as well.
Yep. And fourth grade, based on teacher feedback that we had, they wanted a review of division. So we tied in division really strongly with the factor pairs so that when they go through the division sentences and they run the algorithms on the KaiBot, that they actually come up with the ordered pairs. So you have unordered pairs where you're just putting just one, like 1 and 12. But then the ordered pairs is 1 and 12, 12 and 1, 2 and 6, 6 and 2. So this is such a foundational concept for students. If you go to the next slide right now with factor pairs, I put in here why it matters. It matters because of the commutative property. They need to understand that 2 times 8 is the same as 8 times 2. Same thing with those ordered pairs. It also gives them all the graphing connections when they start graphing these ordered pairs on 4-quadrant graphs. It leads to area models and understanding the area of a rectangle. And also algebraic thinking, where they start to put the XY pairs together. They start doing, like X plus Y equals 16, or they even start going into linear equations. Factor pairs are so foundational. We really need students to understand what those are. And I really think the KaiBot brings that kind of learning to the next level.
So when we talk about, you may say, okay, well, we want to bring this into, your standards. So what standards are you looking at? Are you just sort of doing I know each state is different, but is it like Common Core, or is it based on computer science, or how does that work?
So all the standard alignments are based on the math standards, on the Common Core state standards, and there is a spreadsheet that you can have access to. I don't know if you have the spreadsheets online for you, Ronell, but if anybody just emails, I can give them access to the spreadsheet that has all the standards alignments for every state.
Yeah, I'll show that afterwards with the lesson plan, so it's all in there as well. So no, I mean, this is really, really good. Okay, so we've reviewed that division and factor piece, because I think this is the problem that sometimes happens. If we don't get the fundamentals of math, if we don't nail that down in the beginning, when you get older and you start getting into algebra and all of that, it becomes really complicated if you didn't get those fundamentals right.
Yeah, they're all building blocks. Every single math skill builds on another. And if you have a hole, it's hard to fill that hole going off in different areas without backtracking.
Yeah.
So fifth grade, we're laying the foundation for input-output tables, which in middle school will lead to functions. So we do this in a very systematic way. There's actually 4 fifth grade lessons in order to do that. So we begin really, really simple with 1 input and 1 output. So in this, we're setting a variable. So if I set my variable to 3, and then I increase my variable by 2, if my variable equals 5, then, and I put in a color here, then I want the KaiBot to light up green. And then you end the if statement. So if I do this correctly, and in the Explore worksheet, they have to identify what they're increasing their inputs by. So in this case, we're just doing the example of setting the variable to 3, increasing by 2. And then I have to know that, well, if I do that, what is that value going to equal? It's going to equal 5 in this case. And I want to make my statement true so that it lights up green.
Yeah.
If the students don't, if the students put an incorrect number in, like let's say they put 7, then it will not light up green. And then they'll have to go back and try again.
Now, can you flip that around? Can you put set the variable to 2, increase it by 3, and then that should equal 5?
No.
You see, this is where it's always, I love this, when you really start, because what that then means, if your variable was set at 2,
and you'd have, and you increase it by 3, you start with 2, and then you have 3, 4, 5, 6, 7, 8.
Yes, that's right. That's right. Wow. Okay. So let me get my head around this. I'm sure the math teachers would.
Well, yeah, and actually I just did 3 by 3, but so you're saying if you switch it, so if I set my variable by 2 and I increase it 3 times, it would be 1, 2, 3, 4, 5, 6. That would be 6, not 5.
Yeah.
Sorry.
Yeah. No, that's good. That's really, I really understand that. And those color ones, just you can actually create different colors. So with a KaiBot, the advanced coding cards, you get your RGB colors, and then you can actually paint your own colors. So that is sort of just something that we added in there, which is just a lot of fun. But variables has always been quite a challenge for me. And when I saw this, and I'm like, okay, I think it is now making much more sense, is how you can increase it. Now, can you also decrease the variable?
You can. In this exercise, we don't go there. In middle school, they'll go there by decreasing, because when they do that, potentially they can end up with negative numbers, and that's not till 7th grade. So we stick in 5th grade to just increasing variables for that reason.
Well, I'm looking forward to those middle school lessons as well. Okay, I think that's really, really good. All right, 5th grade. I think I can pass lesson 1.
All right, so lesson 2, now we're going to set it so that we get multiple input and outputs, not just one variable. So before we were setting it to one variable, now if we want to get multiple ones, guess what we have to put it in? If we have to put it in a loop, because that's the repeating part of it. So here I'm going to set my variable to 3. I am going to increase my variable by 2, but I'm going to put it inside a loop, and it's going to repeat 5 times, which means I'm going to have 5 inputs and 5 outputs. And that's where on the worksheet, the students will have an input output table that they can actually write in the input and then the output. And on the KaiBot, they'll see the variables and they'll pop up as it runs through the programming. So as it runs through the programming, they can fill out their input output tables.
Okay, so
and they still have to determine their ending value, what the ending value is going to be.
yeah, I mean, this is all of a sudden. So now, if my variable is 3, and I'm going to increase that, so it's 3 plus 2 is going to give me 5, and I have to loop that or repeat that 5 times. Is that going to take me to 25?
Well, if you start with 3 and you increase it by 2, you're going to have 5. So you have 3, and then you have 5, and then you have 5, and then you have 7, and then you have 7, and then you have 9, and then you have 9, and then you have 11, and then you have 11, and then you have 13. So you end on 13.
Okay, that makes more sense to me. So my variable is 3. I'm going to increase it by 2. Yep, so it's going to give me 5. Then 5 is now going to be my new variable plus 2. That's 7. 7 new variable plus 2 is 9. And then I keep going. I do that 5 times, and then I'm actually going to equal to 13. Is that right? If I put it in my way of thinking.
Yes, that is correct.
And then I'm going to have a blue color card. Okay. Wow. Okay. I understand this much, much better. Right. I'm ready for lesson 3. I think it's lesson 3.
Okay. So lesson 3 now, we are going to use abstraction and we're going to simplify it. So you have a loop and you have a conditional, and they've learned all about loops and they've learned all about conditionals. Now we're going to introduce a new coding card called a conditional loop. So we're simplifying. So I don't need separate cards. I just need one card that represents a conditional loop. So I set my variable to 3. I start my conditional loop and I increase my variable by 2. And I continue that conditional loop until my variable equals 13.
Oh, okay. So this is much simpler. So basically that loop just means it's going to carry on until I hit 13.
Correct.
Wow. Okay. I learn something every day. This is, I've always said, why do we have a loop and then we have a repeat loop? But and then I know, the developers say, but this is a conditional loop. I'm like, okay, so now this has made it so much simpler. And this is why it's so important that we do bring this into the math class and not just start straight out in computer science, because now that you've explained this to me, I can understand why we use it. So thank you very much.
And then the last 5th grade lesson that we have is an introduction to functions. So now, and people ask, well, how do you explain functions to younger students? I said, well, it's like a snowman. If my function is to build a snowman, what are all the pieces that need to go in there? Well, I have to roll out and make the base snowball, and I have to make the middle snowball, and I have to make the head snowball, and I have to put the eyes on. So all those steps go inside the function of make a snowman. So in this case, we're going to set 2 functions. So we're going to use one function to set our variable to 3. We're going to use another function to set or to increase our variable by 2. So we have 2 separate functions. So now I can use those when I actually make my program, and I can say run function 1. That's going to set it to 3. Then I'm going to start my conditional loop. And then I'm going to run my function 2, which is going to be to increase it by 2. And then I'm going to keep doing that conditional loop until my variable is equal to 13. and then end the conditional loop.
So it is just a different way in answering that same question. So if the teacher, how would you ask this question? Because you've now given me sort of three different ways of actually getting that variable to equal 13. So is it just because firstly we used the loop, then we used the repeated loop, and now we brought in the functions, and you can do the same thing with the, you can come to the same answer in your, using those three coding, I don't know, sequences.
Yeah, so you're using a loop and a conditional, and then you're using the conditional loop. And now we're replacing, and we're basically using a function as a container. So think of a function as a container. If I want to change my program now, all I have to do is change my green cards. I don't have to do anything else other than change my value in my green cards. All the rest of the programming can stay the same. So it makes math become easier, and it makes programming become easier because you're just changing little pieces. So if I want to change this problem, I could say set my variable to 5, increase it by 3, and then change the number in green that it will have to equal in order to end the conditional loop. Now, if students put in the wrong variable there for 13, if they put in the wrong variable for the new problem, the KaiBot will just keep going until it cycles out. Because it'll never stop because they put the wrong value in. That's where they got to stop the program and then rerun it to figure out what that variable should be at the end in order to make the loop stop.
And I like the way you sort of say it's like a snowman. You break down your code in little bits and pieces. And that is so important because sometimes we have these long mathematical questions, that you have to try and then solve. But if we can break it down in little bits, then it's going to help you. And then you can go and check every stage if that's correct or not. So, no, this has been really good. So, 3 different ways of getting to that 13, but remember, make sure 13 is the answer that you want to get to. Okay, so 5th grade. Hopefully I can pass this lesson as well. I think I will have to practice that one a little bit, but it does make it more sense, and I can see how to use this now in my computer science class as well.
Yeah, it's really for math, though. I'm going to really push that. This is a math curriculum. So teachers, all you have to do, K through 5, is do 3 lessons a year. Every teacher can do 3 lessons. Just line it up right with the standard that you're teaching for mathematics and let the kids see the math in action through creating the algorithms and programming the KaiBot to do the math. So it's really about that computational thinking. And it's really about, and computational thinking is the foundation of AI. If we want our students to interact with AI, use it ethically, understand what they're doing when they use it, we really need to lay that foundation of computational thinking with our students.
I love that, because I had a teacher the other day to say, why should I teach coding if I can just get AI to do it? And my answer was, then for that same reason, do we need to teach math? And you go, absolutely. I'm like, wow, we need to understand those foundational components with math. And, and I think math comes even before the computer science, because if we don't understand the math, from a math point of view, you're going to struggle even more with computer science. So I absolutely agree. Let's start with the math side, solve it, get the familiarity with the vocabulary as well, because that's the other thing, if it's a loop or unconditional loop, all those things is really important. Okay, so I think that's all good.
Yeah, a computer can write the program for creating conditional loops, but you have to know that you need a conditional loop. Like the computer may not know that. Like the computer's not going to be able to identify that component, but it will be able to code. So that's why, and to me, these lessons don't focus on the code. They focus on the algorithms needed to be able to do math.
Absolutely. So that algorithms really strengthen the math and the application and comprehension. So fantastic. Wow. Okay, so let me go back. I know we're nearly out of time. Let me just stop my presentation. And what I want to do, I can see Samina is with us as well, but what I want to do, let me just come back here. That has been fascinating. So let me just quickly share where all these lessons are. So if anybody wants to see it, I'm just going to go share my screen. So if you go actually here, this is our portal, the lesson portal, learn.kaiseducation.com. You can just click on, you've got KaiBot, these are products. You can click on KaiBot. And then what we've even done, if you just go search in lessons and you just go, see, math in action, just type math in action and all your lessons. Let me just sign in. Be the next. I'm on a different computer. Hopefully it's going to remember me. Yep, log in. And I'm going to KaiBot. This is that little thing. It's going to math in action. And it will then give you all the different lessons with math in action. Action. You will see also under here, you've got your different products. So if you just want to go screen free, you can do that. You've got your different subjects. So everything for math in action is also under mathematics here. And then you've got your difficulty for advanced, or you can just use your grade scale and do that. And on each lesson actually is all the curriculum and everything. So if I actually just come in here, I know this is that folder we were talking about. So for example, Heidi also created these massive coding cards that you can print out, which is very handy. So if we just jump onto, say, third grade lessons, all the lessons, and here, for example, is one of those worksheets, what we were talking about. She's put this start tile, and you can print it out for the students. So that's really good. I can also come back, and if I click on the lesson, you will see here that the standards, the third math standards, it's all here. Open that up. And you'll see here, we've got the Common Core standards, and then down here is every single state. We've put it to that state standards as well. So you can then go and match it for every single lesson. So hopefully that's going to be helpful. So you've got your lesson, you've got the curriculum, the standards, the worksheets, everything is there ready for you to go. Now, if you've got any questions, you can either reach out to us, Renelle at Kai's Education, and I can pass you on to one of the team members, or Heidi, you can reach out to Heidi. Heidi, what is your what is your email?
Heidi at stretchinstructor.com, STRETCH, stretchinstructor.com.
Absolutely. So any district that's really interested in working with us using this program, please reach out. We're hopefully going to get a white paper that we can share with the districts with Durango, and Heidi is leading this. So, we can't say thank you enough to Heidi for what she's done and really bringing it into that math curriculum. From us, thank you so much. Have a lovely rest of your day, and we talk again soon.